Let's look at practice problem 23.3. The Nuclear Test Ban Treaty of 1963 brought an end to the atmospheric testing of nuclear weapons by all nations but France and China. This testing released the radioactive isotope strontium-90 into the atmosphere. Just as with iodine-131, it settled out of the air onto grass and fields, was eaten by cows, and wound up in milk that children drank. In the body, strontium-90 mimics calcium and is absorbed into the bones, where its radiation can cause cancer. Its half-life is 28.8 years. Assuming that all of the strontium-90 that is absorbed into the bones of children in 1962 stays there, approximately what proportion remains 50 years later in 2012? You can assume that a child absorbed 100 grams of strontium-90 and find what percentage of that remains after 50 years. So we're going to need the formula for the radioactive decay. So we're going to have A is equal to P times e to the negative lambda times t. So P is going to be the amount of strontium-90 that a child absorbed. So we're going to assume that P is equal to 100 grams. We're looking at 50 years later, so T is going to be 50 years. Now we need to figure out what lambda is. We know that the half-life H is equal to 28.8 years. We can figure out lambda. Lambda is equal to the natural log of 2 divided by H. So that's going to be, if I put that in my calculator, 0.024. So that's rounded to 3 decimal places. So now I can put that all into my formula, and the amount of strontium-90 that's going to be left in the bones of the now adults is going to be 100 times e to the negative 0.024 times 50. So if I put that into my calculator, that's going to be 30.1 grams. And I wanted to find out what percentage is left after 50 years. So I need to figure out what percentage that is. So 30.1 divided by 100 times 100 is going to give me the percentage. So that is just 30.1% of the strontium-90 that they absorbed is left 50 years later. And that's going to be true no matter how much, no matter what amount they absorbed 50 years later, 30.1% is going to be what's left.